So today I'm just going to go through these slides, talk a bit about what is new in the latest Ceph release Pacific, which is due out in the month of March, so just a few weeks away, if all goes well. All right, so there are just a few introduction slides here that we'll go through quickly. For those of you who don't know what Ceph is, it's software-defined storage, it's unified storage, scalable distributed storage. These are sort of the ways that people describe. What it really means is that Ceph is open source software that's meant to run on commodity hardware with commodity servers and networks and storage devices, and that a single cluster can serve object workloads, block workloads, and file workloads. Ceph is free and open source software, which means it's free to use, it's free to modify and to share. You're free from vendor lock-in, and you're free to extend and innovate using the system. And Ceph is designed to be reliable, to build a reliable storage service out of unreliable components. Data durability, replication, and erasure encoding, and no interruption of service during rolling upgrades and online expansion, and so on. And Ceph is always going to favor consistency and reliability over correctness, and correctness over performance. Although we certainly try to go as fast as we can, still being reliable. And of course, Ceph is scalable. It's meant to scale up with bigger, faster hardware, to scale out within a single cluster by adding lots of nodes, provide more storage, and to federate multiple clusters across data centers and sites, asynchronous replication and disaster recovery. And of course, Ceph is built on RADOS, providing that object, block, and file interface via RTW, RBD, and CEPHFS. We release every year now in the month of March. We are almost coming up on the Pacific release date. So in the next few weeks, we'll be releasing that. We backport bug fixes 2 releases. So Nautilus will reach its end of life shortly after Pacific is released. And you're allowed to upgrade 2 releases at a time. So you can either jump a single release, or you can jump from Nautilus to Pacific or Octopus to Quincy, whatever it may be. So what is new in Pacific? We're going to break this down into sort of 5 topical groups, starting with usability. These are at a high level sort of the focus areas that we're looking at. So on the usability front, most of the work here, or some of the biggest work, is around CEPHADM, which is our integrated orchestration deployment tool. So there's some new features in Octopus, or in Pacific. First and foremost, there's an automated upgrade from Octopus clusters that have been deployed with CEPHADM. It's a single command, and it'll upgrade the whole cluster and take care of all the details in completely hands-off fashion. CEPHADM can now authenticate with private registries, or even Docker Hub, I guess, if you want to get around the rate limits. The iSCSI and NFS gateways are now stable. CEPHADM knows how to deploy automated HA for RGW, so HA proxy and Keeple ID. And there's some details behind the scenes too. You can mark a host in maintenance mode if you know you're going to take it offline, and it'll stop complaining about it. And there's a new exporter agent mode for CEPHADM that runs an agent on each node that improves the scalability and performance, although that isn't turned on yet by default. It should be soon. And of course, lots of robustness and bug fixes, lots of small usability improvements, so on. And there's an ongoing cleanup of the documentation at ceph.com, removing Ceph deploy, for example, and changing references to describe how to do things with CEPHADM. The dashboard is another sort of key touch point for Ceph usability. So we now have a robust and responsive management GUI for all of our cluster operations that manages all the Ceph core services, object, block, and file, and extensions. That includes monitoring, metrics, as well as management tasks. New in Pacific, we have full OSD management. So you can create OSDs with drive groups, filtering by host and drive type and so on. The smart diagnostics are surfaced, and the sort of disk replacement workflows are integrated now. There's some multi-site capabilities now in the dashboard, so you can monitor the status of RBD mirroring across clusters, and the RADOS Gateway multi-site sync also as well. Improved integration with CEPHADM and to some degree ROOK. There's now an official REST API that's fully documented, versioned, and supported. That's actually based on the dashboard internal API. and a bunch of security-related features around setting RBAC policies for logins and secure cookies and sanitized logs and all that stuff. On the RADOS front, lots of small usability improvements here too. Improve the hands-off, the defaults you get when you install the cluster. We use the app map balancer now by default, which is sort of the most reliable and does the best job of keeping utilization across all your OSDs even. The autoscaler has some improvements too for the out-of-box experience so that you don't really have to think about how many placement groups different pools have. It just handles it all automatically. We now automatically detect and report daemon version mismatches. So if you have like a partial upgrade that didn't complete and you forgot about it or something like that, the cluster will tell you that you're stuck in sort of a mixed version cluster and you might want to change that. You can, of course, mute those upgrades, those alerts during an upgrade if you want to. You can cancel ongoing scrubs. The Ceph-S output is cleaned up a bit, so it's a bit more useful. And also there's work going into a framework for doing distributed tracing on the OSD. This is ongoing work in progress, but it allows developers and sort of power users to understand better where latency is being introduced in the data path, integrating with the Jaeger tool that can help with end-to-end performance analysis. On the CEPHFS side, a bunch of good stuff. The multi-file system support has been around for several releases now, but it's finally been marked stable. All the testing is in place to give everyone confidence around that. And there's sort of a new cleaned up entry point for creating new file systems called volumes. So you simply do fs volume create, the name, and that will both create all the data pools, create the file system, and it will also spin up the metadata servers to actually serve that file system automatically, assuming you're using CEPHADM or ROOK. There's also an autoscaler module that you can enable that can adjust the number of metadata servers that are running based on the settings you apply to the file system. So whatever you set your maximum DS at, it'll make sure that many servers are running, plus whatever standbys you want. There is a CEPHFS top command that shows which clients are using the most I/O and performance. It's new, so it's sort of a preview, but it's there. Ongoing improvements to CEPHFS shell, which make it easy to script changes to file systems. There's the ability now to schedule snapshots on a regular basis via a new snap schedule manager module. So you can say daily snapshots or hourly snapshots of different subtrees. The NFS gateway now has first-class support, active configurations for exporting NFS, CEPHFS via NFS. And those gateways are automatically deployed via the Ceph orchestrator, both ROOK and CEPHADM. And there's some initial support for MDS encrypted file support, although the kernel client implementation is still a work in progress. A few other items on the usability and just new feature in that bucket. On the RBD front, there's this new ability to create an instant clone of an RBD image that's stored somewhere outside of Ceph. For example, at an arbitrary URL, maybe it's sitting in S3. You can clone that URL to an image and immediately start reading and writing from it, and it'll do the copy on write flattening stuff in the background. There's built-in support in librd now for LUKS encryption, which is useful for many cloud applications where you don't necessarily want to put that inside the VM, but you just want to have it implemented by librd itself. There's a native Windows driver now that I guess is sort of in a beta phase. We expect to have signed and pre-built drivers available soon, hopefully soon on Ceph.io. But initial testing shows that it has been stable and performant. And there are also some improvements to the RBD NVD daemon, so you can restart it now. Previously, that would map daemons, and now you can restart the daemon without breaking the images that are currently in use. For RADOS Gateway, there are a few key things. S3 select is a way to push query logic down into RADOS Gateway into the storage, something that is supported on AWS, and RGW now supports it, at least when the data is stored in CSV format. The Parquet support is coming later. There's some integration of Lua scripting in the RGW request path, so you can add some smart caching logic and redirect logic. Lots of work going on there. And D3N is a caching tool that is under heavy development by the RGW folks. Some initial versions, implementations of that are available now in Pacific. On the quality front, lots of work, as always, going into RADOS to make the system more robust and reliable. PG deletion, it goes faster now, and it has a smaller impact on client workloads. OSD map trimming is managed better by the monitor. The on-wire protocol, Messenger 2.1, got a revision to improve the security. The Ceph manager is doing a better job managing its use of CPU, progress module, usage issues that have been resolved, and some efficiency problems have been fixed. And also, simple, but we've added the ability to just view the wear level as reported by your SSDs in the system in the device OS output. So you can very easily get a bird's eye view of what the wear level is in those systems. On the CEPHFS side, lots of stuff here too. There's the ability to turn on and off feature bits for certain file system features. So you can prevent older clients from connecting if the file system is using newer features. The online scrub has been improved so that multiple MDSs can scrub in parallel in a collaborative fashion, improving that. Better support for Messenger 2.1 on the kernel side. Support for recovering mounts after they've been blocklisted. So if a client has been kicked out of the cluster because it was disconnected, it can then reconnect and try to recover its session without having to reboot the box or redo the mount. And improvement of test coverage, expanding the test matrix so we have better confidence in the overall reliability of the system. Telemetry and crash reports, a project that's been going on for a while, mainly focused around learning more about Ceph clusters that are deployed in the wild and what bugs users are encountering. There are a whole series of public dashboards that have expanded immensely over the past year. I encourage you to take a look. You can learn all sorts of things about what versions people are deploying, how big clusters are, and so on. There's sort of two categories here. There are telemetry about clusters and about storage devices. So you can also find out like what SSDs, what manufacturers, and what models even people are using, deploying in their systems. So lots to learn there. Of course, telemetry is totally opt-in. Cluster will only send data to the developers if you let it. And if we ever change the information that's being sent, you have to re-opt in. So definitely want to make sure that we're respecting everyone's privacy here and avoiding any concerns. Most of the initial work on analyzing that data has been around the crash reports, mapping it back to bug trackers. There's work right now to try to put that data into Sentry. And then, of course, there's also the device dashboard that I mentioned that gives you all kinds of insight about what kinds of storage devices people are using. Performance, lots going on, as always, to make that faster. So on the BLUESTORE front, this is the primary storage backend for SDs. Lots of work landed in the Pacific release. Lots of work went into BLUESTORE. There's work that enabled the RocksDB database to be sharded across multiple instances of column families. That improves the performance and scalability and reduces the disk space requirements. There's the hybrid allocator, which means that for most OSDs, we use less memory to keep track of allocation. But in cases where we have lots of objects or it gets very full, then we sort of fall back to the sort of consistent memory use of the bitmap allocator. By default, our space utilization for small objects is much better now because we have a 4K min-alloc size, which means that small objects use less space. More efficient caching and better use of our available memory so that we're sort of making the best use of it. And finer grained memory tracking so that we know where memory is actually being consumed, which is useful for diagnostic. On the QoS front, we've been talking about and working on QoS in Ceph for a very long time. And we've finally sort of landed pieces of this that can be used in production systems now in Pacific. So that's exciting. So phase one, we're using the mClock algorithm to schedule between recovery and background work and client I/O. I believe it's not on by default, but we might change that for the Pacific release. I have to double check on that. But you can turn it on. And so these better defaults give better performance out of the system. We've done lots of testing on SSDs here. Looking forward to Quincy, we're going to do some additional testing on hard drives to make sure that we sort of have good defaults there as well, and also get the same performance advantages. And add in more background activities like scrubbing and deletion and so on to make sure that all of those things are being scheduled properly. And sort of looking forward, eventually we want to use the same algorithm to also be able to do QoS between different clients that are using the system and not just between background work and client workloads. So still have our eyes looking forward there. Crimson project has been going on for several years now. This is essentially high performance rewrite of the OSD and data path. Lots of progress. Recovery and backfill are now implemented, which is very exciting. Scrubbing is mostly there. The code has been refactored and on the classical OSD and is now being integrated with the Crimson OSD. And then CStore, which is going to be the new storage backend for Crimson that's targeting both DNS SSDs and traditional SSDs, is making lots of progress. Most of the pieces are in place. It's a matter of sort of gluing them all together and standing up sort of a full working implementation. So the bottom line is that today you can run simple RBD workloads on Crimson using a compatibility layer to run legacy BLUESTORE code. But we're getting very close to be able to use CStore and have sort of a fully functional OSD, at least for replication. So that's exciting. On the CEPHFS front, several performance changes there. Ephemeral pinning, which is sort of policy that pins certain subtrees to different metadata servers. They don't bounce around and they sort of stick where you want them to go. Make it easy to distribute the workload across the servers. That's been in place now and is working and improving performance and scalability there. There's improved capability in cache management by the MDS for large clusters based on experience with larger clusters like those at CERN, and some throttling for client workloads to make sure that works correctly. And then this support for asynchronous unlink and create operations so that the client doesn't have to wait for a full round trip to the MDS has been ongoing now for a while. There's been partial MGS support since Octopus, ongoing fixes and improved testing, and upstream kernels now, and the CentOS 8 Rally-based kernels as well have support for that as well now. So big improvements for like RM-R type workloads and untarring files. Other miscellaneous performance changes on the RGW front, ongoing work to avoid OMAP where it's unnecessary, so replacing certain data structures with simple FIFO queues, which scale much better. There's some negative caching for bucket metadata that helps for certain workloads. The multi-site sync process performance has improved significantly with better state tracking, especially when bucket charting is used. And work around integrating Nginx as an authenticated front-end cache to accelerate read-mostly workloads. And on the RBD front, ongoing refactoring work. So librd has now been mostly entirely rewritten to use asynchronous event-driven model based on the NeoRADOS, which is the sort of the libRADOS event-driven rewrite implementation. So that has led to some performance improvements and just code cleanup and cleanliness and so forth. And that the hope is that will allow tighter integration with SPDK in the future. On the multi-site front, the big item here is CEPHFS now has a snapshot-based multi-site mirroring feature. So you can set up replication targets, remote clusters, bigger than any directory. And a new CEPHFS mirror daemon will take periodic snapshots of the source cluster and then migrate it to the remote cluster. Those daemons are managed either by Rook or by Ceph. As I said, it's snapshot-based, so basically when a snapshot is created on this source cluster, that snapshot gets mirrored to the remote cluster and then applied. So you end up with sort of a full history. snapshot history on both ends. Initial implementation is in Pacific with some caveats. The single daemon is supported initially, and the incremental updates aren't efficient yet. But as these things are fixed and improved, we'll be backporting those fixes to Pacific where appropriate. RGW. On RGW, so the current RGW multi-site supports lots of things. You can federate multiple sites. You can have a global bucket and user namespace, and you can do asynchronous data replication on zone granularity. In Octopus, we added bucket granularity replication as well, but it was sort of in an experimental state because the code was pretty new. With Pacific, we've added all the testing in QA to move that bucket granularity replication out of experimental status. So you can say, this individual bucket, I want to sync between this site and that site. And also, primarily in this release cycle, there's lots and lots of refactoring and code cleanup, building the foundation to support bucket resharding in a multi-site environment, and this whole host of other features that we have planned around multi-site. So a lot of these changes are sort of stacking up and didn't merge in time for Pacific, but most of them don't add sort of user visible features yet anyway. It's mostly just laying the groundwork for future work. So a lot of that's going to merge in sort of the first phase of the Quincy cycle. And so enabling more new stuff for Quincy. And sort of the last category, integrations and ecosystem and so on. So on the Rook front, big thing here is support for stretch clusters, which actually involved a bunch of RADOS work as well to enable this. But the idea is to be able to take a single Ceph cluster and stretch it between just 2 data centers with them on in a third location to add sort of as a tiebreaker. So for example, you would have 5 mons with 2 in each data center and then 1 in the cloud or wherever else. And support for having pools with replication 4, so you have 2 copies of the data in each data center. Sort of corner issues to deal with asymmetric network fails and so on. But that is now present in Pacific, which is exciting and supported by Rook. And CEPHFS mirroring, as I mentioned, is new in Pacific, and Rook has full support for this out of the gate, so you can configure it via CRDs. On the CSI front, sort of MANILA front, integrating with container and cloud platforms. CEPHFS has support for setting up shares via manager volumes module, which gives sort of a unified view of how your file systems and subvolumes are set up in the cluster. So you can drive PV snapshots using the CSI tools. There's new support for the authorization API in MANILA, and the ephemeral pinning for volumes sort of integrated with the pinning. So if you create lots of these volumes, they get sort of distributed across your metadata servers properly. On the RBD front, there's support for de-encrypt encryption with vault key management and integration there. PVs can be snapshotted and cloned, and that drives the RBD snapshots, so fully integrated there with CSI. Topology-aware provisioning is new, and there's also integration with the snapshot-based mirroring that's still in progress, but coming soon. And some other miscellaneous items. There's some effort this year to remove instances of racially charged terms from the codebase and from the CLIs and so on. So things like blacklist and whitelist are replaced with blocklist and ignore list. There weren't very many instances of master slave, but we've pulled them out. So in a few cases, APIs and CLIs were affected. The old calls are deprecated, will be removed in the future. There are ongoing documentation improvements. As many of you are probably aware, the foundation has hired documentation contractors working full-time, just improving and cleaning up the Ceph documentation. So ongoing improvements there. And there's also a website redesign project that's been ongoing now for the main Ceph website, moving away from WordPress to a static site generator built out of repository and Git that we hope is going to launch this spring. The design is together. We're just sort of finalizing information architecture and filling in copy and content, but we're excited about that. Other sort of ecosystem things, we've been talking about ARM64 for years, but we have sort of yet to achieve reliable builds with all of our releases using ARM64 packages. But we finally have a bunch of hardware that is actually fast enough and enough of it to do that, both on the release side and also for CI. So all of our CI builds are producing ARM packages and containers now. So we're excited about that. I think Pacific will be the one where we actually have all of the proper artifacts for ARM. So fingers crossed. We still have limited capacity to do QA and regression testing on ARM just because we have a lot of testing hardware and we can't do all the same things we do on x86 that we do on ARM. But we have some, and so there'll be some testing there. And that's pretty much it for Pacific. The next release after that is going to be Quincy, which will be released next 2022 March. And so as we finish up Pacific, there'll be a whole planning process kicking off around what we're going to be including in that release. Can't really tell you what that's going to be yet because we haven't done the planning. But we do have some virtual events planned for this spring. So the Ceph Developer Summit, of course, is going to happen sometime shortly after Pacific is out, so we can do that Quincy planning and find out what we're going to build next. And that'll have the traditional format that we've been using for years, where it's scheduled topical sessions and it's all online video chat, remote, virtual, whatever. But we are also planning something else that is not targeted so much at developers, but more at users and operators. Because we can't have CEPHLOCON in person, we're sort of trying to figure out how to get the best value that we can for people who would attend CEPHLOCON in a virtual format without sort of overloading you with complicated platforms and whole days of sitting in front of Zoom or whatever it is. So the format we're talking about right now is having a topic per week spread out over the course of a month. So starting out with just sort of core Ceph and what's new in Pacific and a few high-level things there, and then having a week dedicated to stuff that's new in RGW, RBD, and CEPHFS. And just like maybe 2 or 3 scheduled talks over the course of the week. Always including and starting with the developers presenting what's new and what's coming up in that new release, and then some other interesting technical talk that you might have seen at CEPHLOCON. But then following those talks with sort of semi-structured and unstructured discussion that feels more like a meetup. So there's sort of an informal agenda with open discussion. Users and operators can talk about what's coming and problems they've been having and features they've used or haven't used and so on. Compare notes about what's going on. So hoping to make that sort of a useful, meaningful way for Ceph users to interact with each other. We'll probably have lightning talks scheduled in there somewhere. And this would all, of course, be fully virtual, so video chat and recorded for future people to come look at. And not too much time at once, so not going past, a couple hours a day. Don't want to overwhelm people. And that's it. Thanks. That's what's coming in Pacific. I'm happy to answer any questions. And of course, you can always come find us on IRC or on the email list. Thanks.
Somebody asked a question in the chat.
What's the issue with RBD NVD restarting in prior versions? So my understanding is that if the RBD NVD daemon would stop, then the block device would go away. And you would have to start up a new one. If you restart the daemon, it'll create a new block device, but the thing that was using the old block device would be hung. And the change is that, as I understand it, you can restart the daemon and the block device that you're already using will continue to function once the daemon is restarted. What is the plan with CentOS deprecation? Now there's a loaded question. I'm not sure if deprecation is the right word. CentOS is changing instead of having sort of fixed releases that don't change. It's sort of more of a rolling release. My assumption is that we're just gonna transition to basing our containers on the rolling release. I don't know if that means we would refresh older containers for older releases with new CentOS as bug fixes become available. I'm not really sure. It's not like we've done that when new point releases come out. I don't expect that it's going to change much, to be honest. But we'll see. We haven't had to deal with it yet. Yeah, there's so much like angst and confusion around the whole CentOS change. I think it's I don't know, a little bit blown out of proportion. But from our perspective, we just need a stable operating system image to put inside the container, and CentOS stream is going to fit that bill just as well as the latest point releases were. I can tell. So. Let's see, what is the status of CEPHADM? How big of clusters is it designed for? So CEPHADM has been supported since Octopus in Pacific. It's got lots of improvements. We've also been backporting stuff. It works pretty well as is. The main issue is that when your clusters get really big, it can be kind of laggy in terms of like hoovering up the status of whether containers are running, for example, across all the nodes, because it's going like one node by node. So I'm not sure I would use it on a cluster with more than like 30 nodes maybe currently. I don't know, or in there. But there's the CEPHADM exporter work that is like 90% done. That basically runs an agent on every host that's doing all the local scraping. And then it's a very fast process to just like query all the agents and just get the latest status. And so that will vastly improve the scalability, and I think there won't be any practical limits. I think it should be fine. There are just like a few issues that we need to deal with as far as like making sure things work completely correctly with that mode before we switch that to be the default. I'm not certain that's going to be backported to Pacific. It probably will be as soon as it's done, but yeah, we'll see once it's done. General expectations regarding Crimson OSD. I don't know if Sam's on. He could probably answer this a bit better.
Come on. The time scale is like, I think the consensus is something like next year for early prototype. And then it will be more time as features get added. For instance, at that time, it will probably only, it will only support replicated PGs. And some elements of CEPHFS or RGW may be partially supported. It may take time to get full support for some of the relevant RADOS features. We would hope to have at least some kind of C-store next year, though.
Yep. Thanks. Any other questions? Any plans on deduplication? Yes, that didn't make it into these slides because nothing really landed in Pacific. Except actually one thing did land in Pacific. So there's a tool called Ceph dedupe tool that is, I think it's in the Ceph tests. It's in one of the sort of extra packages. And you can basically give it the name of a pool, and it will do a bunch of reads and sample the data that's in that pool. And then it'll estimate what dedupe ratios you would be able to achieve with different chunk sizes, chunking parameters. So there's sort of some underlying work around the chunking algorithm. But one of the next steps is to figure out like how effective it would be on actual data deployments. So it would be great if you run that dedupe tool on your actual data set that you think you want to dedupe, and you can sort of see what kind of ratios you would get. But it's a trade-off where if you have chunk sizes that are smaller, you get better ratios, but then the read IO is much slower because you're reading all these little pieces that are spread around the cluster. Whereas if your chunk sizes are large, read IO is much better, but then your ratios as good. So that tool will basically tell you what that means, what you get out of that. As far as actually storing dedupe data, there's sort of two paths forward there. One is to make RADOS Gateway directly store data in a deduped RADOS pool. And there's a relatively modest amount of work that would be done in RADOS Gateway to allow to support that. Then there's a separate track that's basically making a RADOS pool an arbitrary RADOS pool with any consumer be deduped. And so like sort of the new fresh active data would be stored in normal replica 3 standard format. And then as the data gets cold, it could be pushed out into a content addressed deduped pool. And that work has been ongoing for a while, but is still not stable and needs additional work. So I'm not sure what the timeline is on like when we will feel confident in being able to really do that. But there's both stabilizing work and additional development to make that fully work.
There's work on dedupe at the RGW level happening now too as well, right?
Yeah, that was the first part I mentioned. It's been sort of on my mental roadmap for a while. I'm actually not sure if anybody has done anything, written any code yet. But I think it's a relatively small amount of code to write in order to support it. So I think we have to have as part of the Quincy planning, we should have a conversation with the RGW folks and decide whether that'll happen or not. And when. Let's see, Dan asks, do we have problems as hard drives gets bigger? I don't know. I don't anticipate problems with wanting to split a hard drive into multiple OSDs. I'm not sure that would be a good idea because I don't think the disks are getting bigger, but they're not getting any faster. And so I don't think having a single OSD fronting a single disk is ever going to be a problem. We might want to increase the PG count. You might be right there, but yeah, I'll be honest, I haven't really thought about that too much recently. There's a question around dual stack IPv4 and IPv6. So you can run either IPv4 or IPv6. And with the Messenger 2 changes, you can even have a mix. So one OSD could have, I think actually, I don't know, it hasn't tested, so maybe it wouldn't work. But in theory, you could have a mix of v4 and v6, but a single OSD can't have both currently. But a lot of the framework foundational work is now in place so that you could conceivably have OSDs binding to both v4 addresses and v6 addresses to support both v4 clients and v6 clients. I don't know how important that really is. I haven't actually heard a real user say that they need it, and so I haven't worried about it, but it could be done. I think it's mostly probably a not too extensive amount of development and then a whole bunch of testing to like make sure things work still. But that's been done. Is there news regarding safe MON backups? Save de-encrypt keys in case of power outages. So in general, you can't really back up the MONs because you have stale MON information, then it's stale and isn't especially useful. But things like de-encrypt keys are easy to back up. Like you can just do a CLI dump, config key dump command, and you can dump them all out to a JSON blob and put that wherever you want. So that sort of backup of that information would be easy, but a wholesale backup of the monitor is not, because the data is constantly changing and it needs to be in synchrony, in sync with the rest of the cluster. So. Yep. All right. Anyone else have anything to add? Did I miss anything? Josh, Neha, Dan?
Don't think so.
Nope.
Yeah, I think we can cover some of these new topics that people have interest in and we haven't delivered in Pacific in our CDS sessions coming up for Quincy. Then we can prioritize based on that.
Yep. Yeah, and maybe now's a good time to mention if there are specific things that you need that we don't do yet, now would be a good time to make your voice heard by emailing the dev list or asking an IRC or whatever so that we know what's important to users when we do our planning.
And
All right.
shout out to the Ceph survey
one
as
question.
well. Check just good feedback for what you're actually using in the wild.
Yes.
I think it's still open until April.
Yeah. I'll put the link in the chat. I forgot about that. Good call. Yeah, if you haven't done the survey yet, do that. Oh, that's not the right one. Sorry. And also, if you haven't turned on telemetry on your cluster, you should do that also.
Was there another question?
All right. All right. Thanks, everyone. Have a good one.